All right, so this is part 2 of section 1.4. So getting back to the book here, the imaginary unit is denoted as I, and we define it as it is that number which, when squared, gives you -1. All right. So this we've already talked about the complex number system. Complex numbers are numbers of the form a plus bi, where a and b are real numbers. The real number a is called the real part of the number a plus bi. The real number b is called the imaginary part of a plus bi. And the fact that it has an I on it is what makes it the imaginary part. -5 plus 6i. The real part's -5. The imaginary part is 6. We put a complex number in the form a plus bi. In other words, we put the purely real part first, and we put the part with the I on it, the imaginary part, second. That's called standard form. All right. If you just have an imaginary part with 0 being the real part, so you don't have to write the 0, you can just write the imaginary part, that's called a pure imaginary number. All right, get some vocabulary here. Okay, we can add, subtract, multiply, and divide these complex numbers. All right, let's get some good examples going here. 3 plus 5i plus -2 plus 3i. All right, so if we add complex numbers like this, 3 plus 5i plus -2 plus 3i, it's very simple. Combine like terms. The numbers that don't have the i's combine, the numbers that have the i's combine. So the 3 will combine with the -2, and you would get 1, and the 5i would combine with the 3i, when you get positive 8i. So the result of part A here is 1 plus 8i. Part B, all right, notice that minus sign. What do we do with a minus sign in front of parentheses? We got to make it into a plus and distribute that minus sign into the parentheses. So everything in the parentheses changes its sign. So that 3 becomes a -3, and that positive 6i becomes a -6i. So now I got to combine it. 6 plus -3 is 3, and 4i plus -6i is -2i. So that's the result of part B. All right, this is an example of multiplication. 5 plus 3i times 2 plus 7i. We have to FOIL this out, or what, as I like to call it, double distribute. So I'm distributing the 5, and I'm distributing the 3i. All right, so let me call this part C. So part C, 5 times 2 is 10, 5 times 7i is 35i, 3i times 2 is 6i, 3i times 7i is positive 21i squared. Now we got to talk about I squared. What is I squared? We've already defined I squared. I squared is defined as -1. Okay? So anytime I get an I squared, I need to remember that is actually -1. I squared is actually -1. So that's going to multiply with that 21 or whatever number's beside it, and it's going to change that positive 21 in this case to a -21. So that whole term right there, I'm just going to rewrite that as -21. So it becomes a real number. And the I squared term becomes a real number because I squared is just -1. So now we've got 10 minus 21, that gives me -11. And 35i plus 6i gives me plus, what is that, 41i. So that is the answer to part C. Okay, next thing I need to teach you is about a conjugate. What is the conjugate of a complex number? So usually, a lot of times we will define a complex number by using the letter Z. So notice right here it says Z equals 3 plus 4i. Okay, so if you define any complex number Z as A plus BI, then the conjugate of Z, you use this symbol above the Z to denote the conjugate. That's the symbol for conjugate. Z conjugate is going to equal A minus BI. So the conjugate will always keep the real number, the real part, to be the same, but it'll always change the sign of the imaginary part. So if this was a minus bi, the conjugate would be a plus bi. All right, so for this example here, I'm going to call this number 1. Find the product of the complex number z equals 3 plus 4i and its conjugate z bar or z conjugate. So if z is 3 plus 4i, then z conjugate will equal 3 minus 4i. And it wants me to find the product of those. So I've got to say 3 plus 4i times 3 minus 4i. All right, so that's going to be 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i is negative 16i squared. All right. Now, remember what I squared is? It's negative 1. So that negative 16i squared becomes what? Plus 16. Because negative 16 multiplies with negative 1, it's going to become plus 16. Now, what happens to the negative 12i and plus 12i? It will cancel. They'll cancel each other out. Become 0i. So what do we get? We just get 9 plus 16, which is what? 25. And that always happens when you multiply a complex number with its conjugate. It'll always just become a real number as a result. Okay. Now, that will help us on dividing complex numbers. Let's do number 2 right here. Write 1 over 3 plus 4i in standard form, meaning it just needs to be a plus bi. All right, let me pause it and erase this. All right, I'm doing number 2 right here. To write this in standard form, I can't have this 3 plus 4i be on the bottom. I can't have a radical on the bottom and I is actually a radical because it's the square root of negative 1. So what I can do is I can rationalize that denominator. 1 over 3 plus 4i. And the way that you can do that is to multiply that denominator by its conjugate. So I'm going to multiply that by 3 minus 4i. But whatever I do on the bottom, as long as I do it on top, then I'm good. I haven't done anything mathematically illegal. I haven't changed the value of that expression. Because multiplying by the same thing on top and bottom is effectively the same thing as multiplying by something over itself, which is the same thing as multiplying by 1. All right, so it doesn't change the value. So what do we get on bottom here? We get 9 minus 12i plus 12i minus 16i squared. We kind of already did this, right? So that gives me plus 16. Those two cancel out, so that's 25. On the top, we just get 1 times 3 minus 4i, which is 3 minus 4i on top. And on the bottom, I got 25. Now, if I want to put it in a plus bi form, what I can do is split this up and put 3 over 25 and put minus 4 over 25 and then put the I right there. And that's the same thing, and I have now put it as a plus or minus bi form. Here's the real part, there's the a, and there's the imaginary part, the bi. All right, that takes care of number 2. Now, let me call this one number 3. Okay, I'm working on this one now. We need to divide this and write it in standard form. Okay, the way that we can do that is we say 1 plus 4i over 5 minus 12i is we do the same thing we just did on the previous problem, which is rationalize this denominator by multiplying it by its conjugate. So multiply that by 5 plus 12i. And as long as I do the same thing on the top, then I'm good. And so there's going to be a lot of multiplication going on here. Need some room. That's going to be on the bottom. I'm going to get 25 plus 60i minus 60i minus 144i squared. So 144i squared, as you know, becomes plus 144. The plus 60i and minus 60i cancel, so 25 plus 144 is 169. All right, so that's my bottom, that's my numerator. That's my denominator. The numerator, the top up here, is going to be, so 1 times 5, that's 5, plus 1 times 12i is 12i, 4i times 5 is plus 20i, and 4i times 12i is plus 48i squared. As you know, that's going to become minus 48. All right, so 5 minus 48 gives me negative 43, and 12i plus 20i gives me plus 32i, and that's going to all be over 169. Okay, so now I just need to split this up, and it'll be negative 43 over 169 plus 32 over 169i. And these fractions, if these fractions would reduce, I would reduce them. But since they won't, this is the answer. All right, now that number 4, it says if z is 2 minus 3i and w is 5 plus 2i, right, then I got to do parts A, B, and C here. I got to do z over w. So 2 minus 3i over 5 plus 2i. That's the same kind of problem I just had. So I'm going to multiply both of those by 5 minus 2i. On top and bottom. Now I'm actually going to skip that because I just did a problem just like it, so you don't need to see another one like that on this video. Part B, z plus w conjugate. That means I got to do z plus w, and when I get that result, then take the conjugate of that result. So that's going to be 2 minus 3i plus 5 plus 2i. So that's going to be 7 minus I. Now I still have to do the conjugate of that. So my final answer is what? 7 plus I. That is the answer to part B here. All right, part C, I got to do z plus z conjugate. Part C. Don't do that. Is z plus z conjugate. So that's going to be 2 minus 3i plus the conjugate of that, which is 2 plus 3i. So what do we get from that? 2 plus 2 is 4. Negative 3i and positive 3i give me 0i, so 4 is the answer. Okay. Next topic is called the powers of I. Not like the superpowers like invisibility or flying or something, but the powers of I means like I to various powers, I to with various exponents on it. So the first thing we can say here is I to the first power is just I to the first power. No duh, right? But I to the second power, we've already said I to the second power is negative 1. Because if you do the square root of negative 1 times the square root of negative 1, you get the square root of something times itself, or the square root of negative 1, the square root of negative 1 squared, the square roots and the square cancel out, and so you just get negative 1. All right, so we've defined it that way anyway, so I squared is negative 1, and just that's something you just need to remember. I squared is negative 1. Say that to yourself 3 times. I squared is negative 1, okay? I cubed is the same thing as I squared times I, right? And so we've already said I squared is negative 1, and so this just becomes negative 1 times I, which is negative I. I to the fourth is the same thing as I to the third times I. Well, we've already established that I to the third is negative I. So now it's negative I times I, which is negative I squared. And we've already said that I squared is negative 1, so this is negative negative 1, which is 1. All right? I know you may be thinking, why are we doing all this? But just follow me for a minute. I to the fifth. I to the fifth is the same thing as I to the fourth times I, right? Well, we've already established that I to the fourth is just 1. So it's just 1 times I, which is just I. And then I to the sixth is I to the fifth times I, which I to the fifth we've already said is I. So this is just I times I, which is I squared. And then I to the seventh is just I to the sixth times I. I to the sixth is I squared. I squared, I should have went on. I squared is negative 1. And so I squared, so this is just, I to the 6 is negative 1, so negative 1 times I is just negative I. I to the 8th is I to the 7th times I. And so I to the 7th is negative I. So we've got negative I times I. So that's negative I squared. So it's negative negative 1, which is 1. Now looky here. We got ourselves a pattern. All right? Because I to the 9th is just going to be I to the 8th times I. So it's just 1 times I. So it's back starting over again at I. So I, negative 1, negative I, 1. I, negative 1, negative I, 1. And it's going to repeat again. If you can remember this, all right, I won, right? I won. Negative sandwich. Then you can remember this pattern. Negative, sorry, I misspelled that. Negative sandwich. I won, negative sandwich. I won, a negative sandwich. Okay. I won, negative sandwich. I negative 1, negative I 1. I won, negative sandwich. That's the pattern. Now what that pattern does is it allows us to calculate any power of I. Just basically with the powers of our mind now. Okay, so let me take just a random one. How about I to the 73rd power? The way that I like to do these is I like to break these down to some multiple of 4. I want this to be a multiple of 4. So I believe 72 is a multiple of 4. So this can be written as I to the 4th. 4 times what is 72? Well, let me write this. Sorry, I should have started over. Okay, this is I to the 72 times I. Why did I choose 72? Because it's a multiple of 4. So I to the 72 can be rewritten as I to the 4th to the what? 4 times what is 72? Well, 4 times 10 is 40. 4 times 15 is 60. And then you need 18th. I to the 4th to the 18th. Well, what is I to the 4th? It's just 1. Remember, I to the 4th is 1. Look right there. So this is just 1 to the 18th, which is just 1. So this whole thing is just going to be 1. So that part's just going to be nothing. Not nothing to worry about anyway. So now it's just 1 times I. So I to the 73rd is just plain old I. That's the answer. Let's do another one. How about I to the let's go 99th. Again, I want to think of the nearest multiple of 4, that like 4 going into 99. So the nearest multiple of 4 to 99 is 96. And then how much is left over from after I to the 99th breaks down to I to the 96 times what? Times I to the 3rd, because you add 96 and 3, you get 99. Okay? And I to the 96, since it's a multiple of 4, that's just going to be 1. So I ain't worried about it. So this is just going to be I cubed. And I cubed is what? Right there. Negative I. All right? That's what the I won negative sandwich can do for you. All right, let's do maybe 2 more. Let's do I to the 28th. I to the 28th is already a multiple of 4, right? This is just I to the 7th. I to the 4th to the 7th. 4 times 7 is 28. And I to the 4th is just 1. That's 1 to the 7th. What's 1 to the 7th? It's just 1. So if it's already a multiple of 4, you're just going to get 1. All right, last one. How about I to the 42nd? Again, I like to break this down to the nearest multiple of 4. So what's the nearest multiple of 4 to the 42? It'd be 40. So it breaks down to the I to the 40th and I to the 2nd. And since I to the 40th is a multiple of 4, that's just going to be 1. So this is just going to be I to the 2nd. And I to the second is what? -1. So your answers to all these are going to be either I, -1, -I, or 1 every time. Now I do have good news for you, and it is that your calculator can do it for you. Like, watch this. All right. You see this button, this blue I above the decimal point? Watch this. Second. Well, I got to get out of what I'm doing. Second quit. So now I'm going to go second I to the, let's just make up a number, 53. And it'll do it for me. It's just I. In fact, you can do something even more than that. You can do like 3 minus 4 I to the third -117 minus 44. It can do a lot of that stuff for you. All right, so yeah. Thus the powers of I. So if you had to write 2 plus I to the third in the standard form, you could distribute it all out or even use the binomial theorem, but maybe you just want to use your calculator and let that do it for you, and that's fine. All right, taking this on to solving equations. All right. Okay, so let's look at this one. Let's call this one number 1. Get my pen going. Let's call this one number 1. All right, so the square root of -1 is just, that's the same thing as 1 times -1, right? So it's just, and the square root of -1 is I, so it's just I, or 1I. All right, let's do the square root of -16. Let me write it a little bit better. Square root of -16. I can make that be the square root of positive 16 times -1. And see, the square root of -1 is just going to be I. So now I can just treat this positive 16 as it is, a positive number. And what is the square root of 16? Well, it breaks down to 4 times 4, so square root means something times itself. So the square root of -16 is 4. But then that -1 right there means it's also the square root of -1, so it is I, 4I. Now to make this really, really simple, anytime you have the square root of a negative number to do this, you can just treat it like it's a positive number. So if square root of -16, just treat it like it's the square root of 16. And what do I get? I get 4. And then just put an I with it. And that will take care of the negative part for you. Treat it like it's a positive number, but put an I with your final result. So if I had the square root of -8, the square root of -8, that breaks down to 8 times -1. We know that's going to give us an I. The 8 breaks down to 2 times 4, and 4 breaks down to 2 times 2. So I got a pair of 2's, but I have an extra 2 left over. That's going to stay in the radical. So this pair of 2's comes out as a 2. That 2 stays under the radical. And then that -1 is going to be an I. Where does the I go? Well, it doesn't go in the radical. It goes outside the radical. So it wouldn't be wrong to put it like here on after the square root of 2, but the standard place to put it, the conventional place, is to put it right there. 2I root 2. All right, now I'm going to do number 2 right here. Solve each equation in the complex number system. So if I have x squared equals 4, how do I solve that? I take the square root of both sides. And so the square root of 4 is 2. So don't forget to put plus or minus when you take the square root of both sides. X equals plus or minus 2. Nothing imaginary about that. All right, part B, x squared equals -9. Take the square root of both sides now. And I get x equals, don't forget to put plus or minus, but the square root of -9, treat it like it's a 9. The square root of 9 is what? 3, but because it's a negative under the radical, I just put an I with it. So my answer is plus or minus 3I. All right. All right, number 3. Solve this equation. X squared minus 4x plus 8 equals 0 in the complex number system. Okay. Sorry for the sloppiness here. But I might try to factor it, right? That might be the first thing I try to do. Can anything multiply to get 8 and add to get 4? No. So it can't factor. So if I can't factor it, I'm going to go to the quadratic formula. Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a over 2a. So that's going to be negative 4 is 4 plus or minus the square root of 16 minus 32 over 2. That's 4 plus or minus the square root of negative 16 over 2. That is 4 plus or minus, what's the square root of negative 16? Well, it's 4i is what it is over 2. And then this will reduce to divide them all by 2. And it divide the 4, and the 2 all by 2. And you get 2 plus or minus 2i over 1. I don't have to put the over 1, so 2 plus or minus 2i. All right. Now number 4. All right, to do number 4, I'm going to introduce you to something called the discriminant. The discriminant. Now, the word discriminant probably reminds you of another word called discriminate. And discriminant kind of is very related to that word. To discriminate is to distinguish a difference between things. It is not an inherently evil word. In fact, you should discriminate oftentimes. You should discriminate when you go buy fruit at the market. Don't buy the rotten ones. If you're, interviewing someone for a job to watch your children, to be a babysitter for your children, you should discriminate against child predators, obviously. So to discriminate is not inherently evil. It's just a matter of why you're discriminating. Why are you distinguishing the difference? It can be wrong, certainly for various reasons, if you do it skin color or something like that. But if you are, what the discriminant does in math is it distinguishes between types of solutions. It tells us what kind of solutions, the nature of the solutions we're going to get from various quadratic equations. The discriminant is this. It is the part under the radical in the quadratic formula. It's the b squared minus 4ac. That is the discriminant. All right, that will tell us the nature of our solutions. If b squared minus 4ac, if it is greater than 0, in other words positive, then you will get 2 real solutions. 2 purely real solutions. If b squared minus 4ac is equal to 0, you will get 1 purely real solution. And if b squared minus 4ac is less than 0, in other words, a negative, if you get a negative under there, negative, then you're going to get 2 complex or imaginary, we can say imaginary, not purely real solutions. So now we can do number 4. So number 4 asks me to, without solving, determine the character of the solutions of each equation. All right, so all I need to do then is the discriminant. I don't need to solve the whole thing. I just need to do the discriminant. So for part A, all right, part A, it's going to be it's going to be 4 squared minus 4 times 3 times 5 right? That's b squared minus 4ac, so that's going to be 16 minus 4 times 5 is 20, 20 times 3 is 60. So that's going to be a negative number, right? It's like negative 54. So the character of these solutions are imaginary, two imaginary solutions. Part B. It's going to be 4 squared minus 4 times 2 times 1. That's going to be 16 minus 8. That's 8, so it's positive. That means the nature of my solutions are going to be two real or purely real solutions. And then part C is going to be negative 6 squared minus 4 times 9 times 1. That's going to be positive 36 minus 36. That's 0. And when I get 0, it's one purely real solution. All right. And that is the end of section 1.4. Good luck to you on that assignment, and I will see you again in 1.5.